So let us start. Good morning, students, to one and all. Today, under the AICTE sponsored Prerana scheme, we will cover the topic related to theory of machines. Okay. So, dynamic analysis of linkages, then your flywheels, similarly vibrations. So, within this span of 2 hours, we will try to cover all these topics, and as the time limit is permissible to us. Okay, so let us start. First of all, tell me, am I audible clearly? My voice is audible?
Yes, sir.
Yes. Good morning, Akshay Shinde. Good morning, Akash Rao. So let us start. I will present my screen here. I am presenting my screen. Okay. Now, the first topic that we will cover is the dynamic analysis of linkages. Basically, see the content related to this topic, dynamic analysis of linkages. These are the contents of dynamic analysis of linkages. Okay, so here determination of force and couple of link, D'Alembert principle, then type of force analysis, then dynamic analysis of 4-bar mechanism. We will see the basic concept, the graphical method. We will just go through it. Okay, then what is a dynamically equivalent system? Then what do you mean by 2 and 3 force members? Where what is the applicability of these members? Then concept of center of percussion. Then the most important part is the analytical method for velocity and acceleration of the piston, force analysis. So these two methods, analytical method for the velocity and acceleration of the piston, and the force analysis. These two methods are very important related to your gate. And why these two topics are important? Because the problems in gate have been asked from these two topics. Okay, then the basic concept of straight line mechanism. So let us start. And please do one thing. If, for example, if my net, because of some glitches in the net, if my voice is not audible or screen is not audible, so you please tell me, okay, so that I can rearrange all these glitches. So let us start. First of all, tell me, screen is now this presentation screen is visible to you? Yes. This screen is visible?
Yes, sir.
Okay, so let us start. Let us start with our topic. First of all, in dynamic analysis of linkages, a student should know the concept of dynamic force analysis. What is dynamic force analysis? That is the basic concept. Now, if we will consider the effect of inertia, okay, inertia forces, okay, if we will consider the effect of inertia forces, then it comes under the category of dynamic analysis of forces. Now, see in this slide, this is the basic proposition of determination of force and couple. Here you can see that there is a rigid body. This is my rigid body, okay, and in this rigid body, let This rigid body is of mass m. Now, this is the center of gravity, Cg of the body, and at point Cg, let two forces F1 and F2. These two forces are equal and opposite forces acting or passing through the Cg. Now, basically, if F1 and F2 are equal, if F1 and F2 are equal, what will happen? They will be cancelled out without affecting the equilibrium of the link. So, thus a single force F, this you can say it as a resultant force. This is your resultant force F. A single force F whose line of action is not through the center of gravity. It is not passing through the center of gravity, but it is parallel to the forces F1 and F2. And this force is very, very capable of producing both linear and angular acceleration of CG of the link. Now, what happens? First of all, as we know that if F1 and F2 are same, F1 F2 will get cancelled, and if F1 and F2 will get cancelled, this resultant force, this independent resultant force will be capable for producing the accelerations. Now, let us assume that this resultant force and this force F2, F2 force and F, these two forces forms a couple. Okay, like this. This is F and this is my force F2, and between them the distance is h. So these two force F2 and F will form a couple. And as we know that what is the basic definition of torque? Force into perpendicular distance. So here torque will be force into perpendicular distance, that is F into h. Also I can say torque will be F2 into h. Okay. Now as I am taking the resultant force, similarly, torque is the for angular. This is for linear condition for angular acceleration. The torque will be product of I into alpha. And what is I? I is mk square, where m is the mass, k is the radius of gyration, and I is your mass moment of inertia. So instead of I have substituted mk square और साथ में है यहाँ पर ये alpha. So this is the basic equation for torque for determination of the forces and couple on the link. That is torque equal to mk square alpha, where mk square is your I. Okay. So what we have learned from this slide or this presentation, that in a rigid body, if from the CG two forces are passing, they are in equal magnitude, opposite in direction, they will get cancelled without affecting the equilibrium. But if there is a resultant force F which is parallel to these two forces F1 and F2, and it is separated at a distance h, then the torque will be produced will be F into h, and similarly the couple which will be formed between F2 and F at a distance h, and this couple will cause angular acceleration in the system. Now let us move to the D'Alembert principle. Basically, D'Alembert principle means addition or summation of all the forces and all the torques or couples in such a way that the summation value is zero. In theoretical pattern, I can say that resultant force acting on a body together with the reverse effective force or inertia force are in equilibrium. For example, if in a body there are two forces, one is your acceleration force F and another one is your inertia force Fi. If these are your two forces, then the summation of F and Fi will be equal to 0. Similarly, if we will deal with the torque, the summation will be T plus Ci equal to 0. Now what happens in dynamic analysis condition? Yes. In dynamic, 1 minute. So what happens? I'm just admitting the students. Okay. Okay, okay. Screenshot mobile से. Which okay, okay. Okay, sir. This one. Okay. So let us continue. Yes, sir, please. Okay. Now let us continue with our part D'Alembert principle. In chem dynamics also, we have studied about the D'Alembert principle. Okay. So the D'Alembert principle, as we have discussed, it says that the resultant force acting on a body together with the reverse effective force or inertia force are in equilibrium. So if I am dealing with the linear force, it will be F plus Fi. F is your accelerating force, Fi is your inertia force. So summation will be equal to 0. It is not necessary. इसमें number of forces और आएंगे. Then torque plus Ci, vector sum of the torques and couple will be equal to 0. And basically what I was discussing there, this D'Alembert principle is used to reduce the dynamic problem into a equivalent static problem. That's why this D'Alembert principle is used. So in this D'Alembert principle, you will see that inertia force plays a very important role. In every equation, you will see the inertia force. And I already have told you effect of inertia forces are considered in dynamic force analysis condition. And what is inertia force? Just an imaginary force which is equal and opposite force which causing the acceleration. Okay. Accelerating force and inertia force are same but opposite in direction. If the accelerating force is moving towards right, inertia force will move toward left. So in between, please tell me, screen is visible and my voice is audible, na?
Yes, sir.
हाँ, okay, very good.
Yes, sir.
मैं बीच बीच में पूछते रहूंगा. Now type of force analysis. Equilibrium of members with two forces, then equilibrium of members with three forces, equilibrium of members with two forces and torque, equilibrium of members with two couples, then equilibrium of members with four forces. So these are the type of force analysis. Now two forces means what? In a system there are two forces acting. It may act in x and y direction or in any other direction with respect to x axis and with respect to y axis. Similarly, equilibrium of members with three forces. For example, see, if I will draw now, let us consider this is a beam, two force member. For example, equilibrium of member with three forces. In engineering mechanics, you have studied Lami's theorem. These are the three forces acting. Okay. Similarly, in two forces, law of parallelogram of forces, equilibrium member with two forces and torque. For example, in a system, a couple is acted, then equilibrium of members with two couples, there are two couples. Here there is one couple, and also, for example, here there is another couple. Then equilibrium member with four forces. So likewise, number of conditions can be arrived. And through these conditions, we can find the dynamic analysis of the link member. So just see the basic procedure, a basic line procedure of dynamic analysis of four link mechanism. First step will be to draw the velocity and acceleration diagram. In kinematics of machine, you have drawn the velocity and acceleration diagram. Okay. First, you have to draw the configuration diagram. Then by finding the velocity of crank, you have to draw the velocity diagram. After drawing the velocity diagram, you have to determine all the linear velocities and angular velocities of each and every link. Then by taking the scale, we have to draw the acceleration diagram by using the centripetal or radial acceleration and tangential acceleration magnitude, and then converting it into a scale. Okay. After that, step number 2 will be to find linear acceleration and angular acceleration of the links. Then step number 3 will be to determine inertia forces and inertia couples by using the relations which is mentioned here, Fi equal to minus Ma and Ci equal to minus I alpha. Okay. Say in inertia forces, it will be the mass, and in inertia couples, mass will be replaced by mass moment of inertia. In inertia forces, it is a linear acceleration, and in inertia couple, it is replaced by angular acceleration. And negative sign means opposite to the accelerating force. Okay. After that, the next step is to replace the Fi with equivalent offset inertia. And similarly, the last step will be analyze the mechanism assuming equivalent offset inertia forces on the links. So this is the basic step to determine the. जी sir. uh, okay sir, at 12:30, so sir we will do one thing. Minute sir, 1 minute. So let us continue now. Equivalent dynamical system. Now, what is equivalent dynamical system? In equivalent dynamical system, there are three conditions which has to be satisfied in a system. If these three conditions are satisfied, then the system is known as the equivalent dynamical system. So these three conditions are: the first condition is that sum of their masses is equal to the total mass of the body. It means that sum of the masses, see in this figure here, sum of the masses will be equal to the total mass of the body. For example, M1 and M2 are the two masses, okay, in the rigid body. So sum of M1 plus M2 is equal to what? M. This condition has to be satisfied. Then second is the CG of the two masses coincide with that of the body. The third condition is sum of moment of inertia of the masses about their center should be equal to the moment of inertia of the body. It means that moment of inertia, that is I of 1 plus moment of inertia I2, should be equal to the total mass moment of inertia of the body. This is I1m, this is I2m, and this is Im. So if these three conditions are satisfied, then the system is known as equivalent dynamical system. So basically, in order to determine the motion of a rigid body under the action of several external forces, it is usually convenient to replace the rigid body by two masses placed at a fixed distance apart. And if this procedure is followed and all these three conditions are applied, then the system is equivalent dynamical system. So this is the basic concept of equivalent dynamical system. Now let us see two force member and three force member. Here you can see there is an example of a cable. Okay. So what is a two force member? If an element has pin or hinge support at both ends, you know what is pin or hinge support, and carries no load in between, it is called a two force member. Here you can see that this is a attachment, a bracket attachment. At one end there is a lamp. Okay, so there are two joints. This is one joint and this is another joint. Here along X and along Y reactions are acting. Okay, it works on the two principle, two force principle. Such type of member is known as a two force member. The basic examples are column, strut, hangers, braces, cables, and in a simple term, we can define that if only two forces act on a body which is in equilibrium, they must be in equal in magnitude, okay, collinear hai, and opposite in sense. If this condition is applied, it is known as a two force principle. Now, similarly, three force member here. Again, I am taking that example, but the arrangement of the forces, I have adjusted the arrangement of forces so that you can properly explain the three force member concept. Here, if three non-parallel forces, why non-parallel? This is, and also they are non-collinear, okay? They are not passing through a certain point. If three non-parallel forces on a body in equilibrium, then it is known as a three force member. Now, for example, um, take the caliper of free body diagrams. For example, free body diagram of a jib and crane mechanism. That is the example of three force member. Okay. Here forces are not parallel, but they must be concurrent. A three force member is often an element which has a single load and two reaction. So there will be two reaction and load will be single, and best applicable in free body diagrams where we apply the Lami's theorem. Now the next part is the center of percussion. Now what is center of percussion? The point at which there will be no reactive shock produced. For example, at that point, the translatory and rotatory, that is your translational and rotational motions cancel at the point. The motions are cancelled at the point. Let us see this diagram here. Uh, I will give you one example, a best example of center of percussion, so that you will always know what is the basic concept of center of percussion. See, in cricket bat or in baseball bat, when we are batting, and if the batsman strikes the ball, okay, sometime what happens? There are two parameters. One parameter is that a batsman is batting, it strikes the ball. The striking is so effective that there is no vibration on the handle, and the ball speeds away and go out of the boundary. Okay. Similarly, what happens sometimes if we are batting, as the batsman strikes the ball is the ball strikes at a certain point in such a way that a genuine vibration is created on the handle. So these are the two examples. Center of percussion is the sweet spot of the bat. So what happens? It is the point where impulsive blow is struck, okay, and there will be no reactive shock. Let us take the example of baseball or bat. Here you can find the basic concept is that the center of percussion is a spot which is below the CG of the system, and in that spot the rotary translatory motions cancel, and because of this cancellation an impulsive magnitude of blow is developed, and that point is the center of percussion. So at the center of percussion point there will be no reaction force which will be felt. Similarly, it is based on the conservation of momentum and also the conservation of angular momentum concept. So this is the basic example of center of percussion. So for example, if you want to define center of percussion, you can directly say that it is a point which produce a very high impact and there will be no reactive shock at that point because the translational and rotational motions get cancelled. Now let us move to a main important topic, that is the approximate analytical method for velocity and acceleration of the piston. Okay, so here see it is a single slider crank mechanism, and from here please, this is a very important topic. So I will request all the students that please carefully in this topic please be careful and properly see that this topic is actually understand from your side. Okay, so again let us start. So in this figure it is a single slider crank mechanism. Also I have taken the crank and connecting rod system of a reciprocating steam engine. In your kinematics of machine you have learned about the graphical method. Okay, but in GATE exam analytical method and the numerical based on an analytical method comes. So as in a graphical method, what we were doing, we were finding the velocities and acceleration, then velocity of slider, then angular acceleration, angular velocities, and all the linear and angular velocities for each and every link. So similarly, in analytical method, we have taken the example of reciprocating steam engine, where you can see that this is my fixed point, this is my fixed point O. This is the crank which is rotating at an angle theta from inner dead center. This point is IDC and this point is outer dead center. And this is the connecting rod. For example, here the position of the slider is this, and after certain instant the position of the slider is like this. Okay, so this is the displacement of the piston or slider. Now for example, when this crank OC will overlap at this position, it will become O2 C dash. So now the position of crank will be like this. So from here up to this distance, this will be the connecting rod. So C dash and P dash will be your connecting rod, and this is the maximum limit of the piston. Okay. Now, similarly, when this crank OC will be in this position, which position? O2 C double dash. At that point, the position of the piston will be changed and we will get two positions. One will be your maximum, another one will be your minimum position. Now let L, this is your L be the length of the connecting rod, and this is your R be the radius of the crank. Similarly, there is a term which is known as the ratio, and that ratio is n, very important ratio. And this ratio is the ratio between length of the connecting rod to the radius of the crank. Okay, let phi be the angle of connecting rod from the horizontal axis and theta be the angle of crank. Okay, now through the similarity or by using the sine rule, I can say that L sine phi, L sine phi, which is equal to R crank, R sine theta, very important. This is applying sine rule. Okay, L sine phi equal to R sine theta. Now let us move. So in approximate analytical method for velocity and acceleration of the piston, this is the equation of displacement of piston. Okay, xp is what? Xp is the displacement of piston, displacement of piston. In theory of machine book, by S.S. Ratan, then by Ambigar, then by Sharma in Purohit, okay, then in P.L. Balani, all these books, you will see the thorough derivations of this acceleration. But here in our class, we are basically attached with the gate numericals and how to solve the gate numericals by using these relations. So I am just going through the equations. Now there are two equations here: HP, displacement of piston, in terms of L. L is your length of connecting rod, and displacement of piston in terms of R. Okay, these are the two equations. XP equal to L in the bracket 1 minus n square minus sine square theta upon n plus R 1 minus cos theta, and similarly the next equation. So this is the equation for acceleration. Similarly, next is the velocity of piston. In velocity of piston, VP. In velocity of piston, VP equal to omega R in the bracket sine theta plus sine 2 theta upon 2 under root n square minus sine square theta. अब यहाँ पर ऐसा है बेटा कि since we know that in a single slider mechanism or in a reciprocating steam engine mechanism, for example, this is your slider. Okay, so in practical condition, the crank length, this is your crank and this is your L. So always you will find that length of connecting rod will always be greater than a radius of the crank. Okay. And what is N? N is the ratio of L by R. Since L is always greater than R, it means that the value of N will always be greater than 1. And if the value of N is always be greater than 1, it directly signifies that the sine theta angle will be less than 1. Hence, it may be termed or it may be concluded that the square value of the ratio of length of connecting rod to the radius of the crank will be greater than the sine square theta value. So basically what happens here, the final equation for velocity of piston reduces to Vp equal to omega r sine theta plus sine 2 theta upon twice n. These terms get cancelled out. Okay. So n square को बाहर ले लेंगे आप तो n बचेगा, तो this is the expression for velocity of piston. Now approximate analytical method for determining the acceleration of piston. Acceleration of piston, this is acceleration. It is omega square r. What you have done? This is your velocity. Okay, आपने इसको differentiate कर दिए, so it will come to acceleration. ओके, ये था आपका वेलोसिटी. वेलोसिटी को आपने डिफरेंशिएट किए तो आपको मिल गया एक्सेलरेशन. So the basic formula is omega square r cos theta plus cos 2 theta upon n. This is the basic equation. Now what happens at the inner dead center position? The angle of crank will be zero because it will overlap like this. In inner dead position, what will happen? For example, see this figure. In inner dead position, this crank OC will overlap, will come in this position, and it will become what? OC dash. Okay. So during this position, if theta equal to 0, the equation will be reduced to what? R omega square cos theta means cos 0 will be 1. So 1 plus this will also be 1 upon n. So see, this equation when theta crank angle is 0, this equation is reduced to this term. And similarly, when theta equal to 180 degree, okay, then at that time the equation becomes r omega square minus 1 cos theta minus 1 hai plus cos 2 theta is 1 upon n. And please make a point that maximum acceleration will occur when the crank angle is 0. I have mentioned here, okay, because in the question sometimes, if for example if the angle of crank is 45 degree, then you have to use this equation. If in the question it says that determine the maximum acceleration, so by default you should know that maximum acceleration will be developed when theta equal to 0. So directly you can use this equation, okay, and find out. So I can say that for maximum acceleration the value of theta will be what? 0. And when theta equal to 180 degree, we will get this equation. So proper reading the question is very important in gate. The last is your angular velocity and angular acceleration of your connecting rod. So angular velocity is omega pc and angular acceleration is alpha. So value of omega and value of alpha is given. Here the angular velocity is omega cos theta by n, and if we will differentiate angular velocity with respect to time, we will get angular acceleration, that is minus omega square n by sine theta. Okay. Now, next important part is your force analysis. First part is completed, that is velocity, acceleration, velocity of piston, acceleration, and displacement of piston we have seen. Now, what is force analysis? For example, if we have to analyze the different parameters, such as what will be the effective driving force, that is your piston effort, what will be the force which is produced along the connecting rod, the thrust on sides of the cylinder, what will be the crank effort, and what will be the thrust on the bearings. If all these 5 points are considered, then it comes under the category of force analysis. Why? Because in any engine, it will act upon various forces. Okay. And those forces will be the weight, will be the reciprocating masses, then connecting rods, then gas forces will be there, then frictional force, inertia force due to acceleration and retardation of engine element. And if we will consider all these forces and we will uh, pour all these forces in this 5 category: piston effort, force effort, thrust on cylinder, crank effort, thrust on the bearing, then the system is under, or it is subjected, or it is induced, and it has been known as the force analysis system. Now see, in this diagram there is a reciprocating mechanism of a steam engine which is mentioned. Similarly, the first thing that I will explain you is the piston effort. These are the 5 effort: piston, piston effort, then force along connecting rod, then thrust, then the crank effort, and then the thrust on the bearing. So let us see what is the piston effort. In simple language, it is the force or it is the effort which is applied on the piston. That is your piston effort. But technically, piston effort can be increased or it can be decreased. How it can be increased or decreased? Let us see. 1 minute. Okay. How it can be increased or decreased? Let us see. Now, during first stroke or during the first half stroke, what will happen? When from inner dead center during a first stroke, total stroke is 360 degrees. So during 0 degree to 180 degree, what will happen? When the crank will move from 0 degree to 180 degree, the reciprocating masses will accelerate and inertia force will try to resist it. So what will happen? The net force on the piston will decrease. Similarly, during the next half, that is from 180 degree to 360 degree, the reciprocating masses will decelerate. And as usual, inertia force will oppose the deceleration. And as it is decelerating and inertia forces are opposing it, the effective force on the piston will increase. So the total net force on the piston will be because of the pressure force, because of the friction force, and third, because of the inertia force. These are the three forces which will be acted. Okay. Now let us see what is pressure force, then what is friction force, and what is inertia. Inertia force, you know that inertia forces are actually equal in magnitude and opposite to the accelerating forces. Friction force, that is your frictional resistance, which is developed because of the movement of the cylinder piston arrangement. Let us see the pressure force. Pressure force is nothing but your gas force, which is applied on the either side of the piston under the cylinder when it is in a working condition. So let us see here. What I have done. This is my piston. Okay. This is my piston. तो हमने क्या किया है? I have drawn the free body diagram of this piston in the next slide. See. This is the piston. Okay. So this side here, the pressure which is acting will be P1A1. Okay. And similarly here the total pressure will that will be acted will be P2A2. Stress is what? Load by area. So what will be the load? Stress into area. Similarly, I can define pressure, force by area. So force will be pressure into area. So here P1A1 is the pressure which is acting on the free side, and P2A2 is the total force which is acting on the connected side. If I will draw a free body diagram, it is like this. This is my piston. ये हो गया हमारा piston. Okay. Now with the piston here, there will be a piston rod. This is my piston rod, and this is the free side. So let us assume that this side, the diameter of the piston is D. Okay. So the cross sectional area here will be what? It will be pi by 4 d square. This is the area. Here, if I will see the side view, so in the side view, it will be like this. D, okay, and this is the area. So the outer diameter is D, but as this piston rod is connected, let us assume that this diameter is small d. So it is somewhat a hollow cross-sectional area. So here the area will be pi by 4 capital D square minus small d square. Now gas force Fp. Let us assume gas force is Fp. So what will be Fp? P1A1. P1A1 is this side. This is the gas force which is acting, and this is P2A2. ऑपोजिट डायरेक्शन, इसलिए P1A1 माइनस इफेक्टिव गैस फोर्स विल बी, दिस इज प्लस एंड दिस इज minus positive x negative x, so it will be P1A1 minus P2A2. And I've told you ki the A1 is pi by 4 d square and A2 will be what, pi by 4 capital D square minus small d square, where capital D is the diameter of the piston and small d is the diameter of the piston. So this is your A1 and this is your A2. Okay, so this is the gas force. Next is your frictional force. See, frictional force is positive frictional force and it is also a negative frictional force. Now, positive and negative frictional force means when the crank will move from 0 degree to 180 degree, okay, then it will be termed as negative frictional force. So why negative frictional force? Because during first half of the stroke, the net force on the piston decreases. Similarly, during second half, when the crank will move from pi from 180 degree to 360 degree, it will be considered as a positive force. Why positive force? Because at that point the net force will increase. Okay. So when we have to use negative F and when we have to use positive F, 0 to 180 degree, effective force is reduced. So minus F. 180 to 360 degree, effective force increases, then positive F. So this is the concept of frictional force. Next is your inertia force. So basically inertia force and accelerating force are same. And what is accelerating force? Product of mass into acceleration. So here also the accelerating force will be product of mass into acceleration. This is m into a. This is mass. And what is acceleration? In the previous slides you have seen acceleration equation is r square cos theta plus cos 2 theta by n. Okay, and if maximum acceleration is there, then theta will be 0. And if theta will be 0, so it will be mr square upon, it will be 1 plus 1 by n, 1 plus 1 by n. So this is the inertia force. This is your gas. So totally, what will be the piston effort? It is the summation of gas pressure force, frictional force and inertia force. तीनों को आप ऐड करो, Fp, inertia force will be always opposite direction. That's why यहाँ पर minus क्यों है? Because inertia force will always be in opposite direction. Okay, so here it will be minus. So minus Fi and plus minus F. Plus F कब लेना है? 0 से 180 degree, minus F when 180 degree to 360 degree. Okay, it is inertia force. Inertia force is always in opposite. Fa equal to Fi, but in opposite direction. That's why I have used minus Fi. So this is the piston effort when your engine is in horizontal or piston is in horizontal position. For example, if this is applicable when system is like this is horizontal axis and here this is your system. Okay. For example, for vertical engines, it will be like this. Okay, like this. This is the vertical setup. In vertical setup, the weight comes into picture. Which weight? Weight of the piston or reciprocating parts also comes into the picture. And that's why see here, for vertical, if arrangement is like this is the equation. If arrangement is like this is the equation. Okay. Now see here, F equal to Fp is included, minus Fi is included, plus minus F is included, and plus minus Nb. Why plus minus Nb? Plus minus Mg depends upon the position of this system. Either it is like this or it is like this. Like, okay, according to this position. Here it will be a fixed point. This is the fixed point, and this is your crank. See the position. In first figure, the cylinder position is upward, and here the piston position is upward, and here the piston position is downward. So for this position, positive plus mg, for this position, negative minus mg. Now, force analysis. So here we have seen the piston effort. Piston effort is Fp minus Fi plus minus F. Now we will see force or thrust along the connecting rod, and second, thrust on the sides of the cylinders. Okay. So in this diagram, again, single cylinder reciprocating steam engine. This is your crank. This is your crank pin. Connecting rod. Here the force. If I will draw a free body diagram, this is my piston. So vertical pass along the vertical axis. This is the normal force. This is the piston effort F that we have seen in the previous slide. Normal force means what? Normal reaction. Normal reaction or normal thrust or simple reaction which is acting on the cylinder wall. These are your cylinder. For example, this is your cylinder wall. Okay. Cylinder walls, so normal force acting on the cylinder wall. So this is Fn and this is your Fc. Force on the connecting rod or thrust along the connecting rod, or in simple language, connecting rod force. This angle is beta. Okay, a free body diagram is there. Now, connecting rod on force, that is the thrust along the connecting rod Fc. So what is Fc? If you will draw the trigonometry, through the trigonometry, you can see that cos beta equal to what? F upon Fc. So what will be Fc? F by cos beta. So I've just used the trigonometry rule, nothing else. Similarly, thrust on the sides of the cylinder, that is the normal Fn. So, for example, if I will use the trigonometry sine beta, so sine beta will be what? Fn by Fc. So what will be Fn sine beta into Fc? It can also be known as F tan beta. So Fc equal to F cos beta and Fn equal to Fc or F tan beta. These are the expression which are derived from just simple trigonometry of right angle triangle, nothing else. Okay. Similarly, on this crank pin here you can see there are two forces also. So we have seen the Fc, we have seen Fn. In the previous slide we have seen the piston effort. Now remaining is Fr. This is your Fr and this is your Ft. Ft is your tangential force which is acting from this crank pin. So this is your Ft. तो अगर मैं Ft को बोलूं तो this is perpendicular to this crank R. So what will be the torque? Torque will be Ft into R. And similarly, along this crank, this force is your radial force. Radial force is along this crank. This is your radial force. So see in this next slide, you have determined this Ft. You have determined this Ft and Fr. So what is Ft? So Ft is F upon cos beta sine theta plus beta. And what is Fr? Fr is Fc cos theta plus beta upon F cos beta cos theta plus beta. These are the expressions that you are seeing. Similarly, you should know that Ft is your crank effort, which is perpendicular to the connecting rod. Okay, so I can define crank effort as the force applied at the crank pin, which is perpendicular to the crank and which gives the required turning moment on the crankshaft. So that is your Ft. Similarly, what will be your radial force? Radial force is your thrust, which is acted on the bearings, and it is actually a component of connecting rod Fc along the crank in radial direction parallel to the crank, and it produces a thrust on the crankshaft bearing. and the thrust which is produced on the crankshaft bearing along the radial direction is termed as Fr, whose expression is represented in this slide. Similarly, these are very important concept and rule that, see, this is the sine rule, L sine beta equal to R sine theta, and torque will be product of tangential force into R. So by using these two equations and by using crank effort equation, thrust on the bearing, connecting rod force, and then your thrust on the sides of the cylinder, and your piston effort, this is your piston effort, then connecting rod force, then normal force, then tangential force, then radial force, and this relation. If, please note it very carefully, if a student is capable of understanding this analysis, or if the student has gone through this study, piston effort, connecting rod, normal thrust, crank, thrust bearing, only these three slides, you are capable to solve the dynamic force analysis problem which have come in your GATE exam of previous 20 years. From 2020 पीछे चले जाओ 20 साल जब से, ठीक है, जब भी आए you can solve it. So what I will do, I will just take some numericals for your understanding point of view. But before going for the numerical, voice and screen सब बराबर audible है. Start करें numericals.
Yes, sir.
Okay. Now see, in dynamic for ये 2 मार्क का तो आपको मिलना ही मिलना है. In dynamic force analysis, for example, um, generally problem related to what, स्लाइडर क्रैंक मैकेनिज्म, स्लाइडर क्रैंक मैकेनिज्म रिलेटेड क्वेश्चंस आते हैं, नथिंग एल्स. इसमें कोई 4 बार तो रेसिप्रोकेटिंग स्टीम इंजन है, तो नेचुरली इट विल बी अ सिंगल स्लाइडर क्रैंक मैकेनिज्म, नॉट अ 4 बार मैकेनिज्म. एंड दिस एनालिटिकल मेथड and this analytical expression is derived for reciprocating steam engine, which is a slider crank mechanism. So let us start in the first problem. The first problem says that slider crank mechanism is shown in the figure. Okay, this is your slider crank mechanism. Then it says that, okay, 1 minute. Then it says that the crank angle is 45 degree. I will select the pen. Okay. So see, this is my fixed point. This is my slider. So this angle will be what? This angle will be angle of crank theta, and this angle will be an angle of connecting rod beta. R will be the radius of crank and L will be the length of connecting rod. Here, this is your force, net force acting on the piston. Now the question says that a slider crank mechanism is shown in figure. At some instant, the crank angle is 45 degree. Crank angle is 45 degree. So theta equal to what? Theta equal to 45 degree. Okay. Theta is 45 degree. Force of 40 Newton is acting towards the left on the slider. Force is also given you. कितना given है आपको force? 40 given है. The length of crank is 30 mm. So radius of crank is 30 mm and connecting rod is 70 mm. ये R और L आपको given है. आपको theta given है 45 degree. Similarly, आपको force acting on one side of the piston is also given 40 Newton piston force. Ignoring the effect of gravity, ग्रेविटी यानी एमजी कंसीडर नहीं करना है, फ्रिक्शन इनर्शिया फोर्सेस को भी इग्नोर करना है, एफ एंड एफ आई भी नहीं है. हमको वी हैव टू फाइंड व्हाट, वी हैव टू डिटरमाइन द मैग्नीट्यूड ऑफ द क्रैंक शाफ्ट टॉर्क. फॉर एग्जांपल, इफ दिस क्रैंक इज रोटेटिंग इन दिस डायरेक्शन, ओके, सो दिस विल बी द टेंजेंशियल फोर्स एफटी. at 90 degree. So what will be the torque? The torque will be T equal to Ft into what? R. Okay. So what will be the torque in the solution? What will be the torque? Torque will be product of Ft into R basic. Now, what is Ft? Ft is the thrust. So see here, what is Ft? Ft is F upon cos beta sine theta plus beta. So Ft is F upon cos beta in the bracket sine what? Theta plus beta. So this is your Ft. Okay. And into multiplied by R. So we have to determine the torque up to 2 decimal places. So as F is given, इसमें से कौन से टर्म गिवन नहीं है बताइए. टेल मी कौन से टर्म गिवन नहीं है. 1 minute, हाँ. आई एम जस्ट कमिंग 1 minute. Yes. Which terms are not given? Here, see, Ft is given to you. Ft is given. Instead of Ft, we have substituted what? F. Theta is also given. R is also given. Given क्या नहीं है? Beta is not given. How to find beta? Here, I have explained you the relation L sine beta equal to R sine theta. This is very important relation. So, as L sine beta equal to what? R sine theta. R sine theta. So from here, L is 70, sine beta, R is how much? 30, sine theta, 45 degree. So from here, I can find what? Beta. So beta will be 17.6406 degree. Now, if you will substitute torque equal to F, F is how much? 40 divided by cos of beta 17.6406 multiplied by sine theta plus beta. Theta is 45 degree. Beta is 17.6406 degree into R, radius of crank. Radius of crank 30 mm, substitute in meter. Be careful. Okay. So from here you will get the answer 1.1183 Newton meter. So this is your crankshaft torque needed to keep the mechanism in equilibrium. Okay. Now let us read the second problem. A slider crank mechanism has slider, okay, slider mass of 10 kg, then stroke of 0.2 meter and rotates without a uniform angular velocity of 10 radian per second. The primary inertia forces of the slider are partially balanced by a revolving mass of 6 kg at the crank placed at distance equal to the crank radius. Then neglect the mass of connecting rod and crank. Then when the crank angle is 30 degree, the unbalanced force normal to the slider axis is how much? So first of all, what we will do? We will draw the diagram. In the data, this is my slider crank This is my slider crank mechanism. Okay. The question says that a slider crank mechanism has a slider mass of 10 kg. So mass of slider ms equal to 10 kg. Similarly, stroke given है. Stroke length is how much? 0.2 meter. Now you should know that if stroke is given, you can determine, if the value of stroke is given, you can determine the radius of the crank. How? Because radius of the equal to stroke by 2. So 0.2 divided by 2 equal to 0.1. You should know, you have to know this relation. Stroke is the maximum and minimum position of the slider, और अगर सेंटर से उसको मैं डिवाइड करूंगा तो क्रैंक का जितना रेडियस है उतना वो फ्रॉम द सेंटर, that will be the stroke on both sides from the origin. Now similarly, a primary inertia force of sliders are partially balanced by a revolving mass of 6 kg at the crank. Okay, for balancing, what the question says, for balancing, this is the crank. ओके, तो यहां से लेके यहां पर एक फोर्स लगा दिया है, बैलेंस फोर्स, लाइक दिस, एंड दिस बैलेंस फोर्स is of 6 kg for balancing. When if this force is not attached, it was unbalanced condition. After attaching this force, it is a balanced condition, and this angle of crank is given 30 degree. This is length of connecting rod, and this is beta, angle of connecting rod from horizontal axis, theta, angle of crank from horizontal axis. Now what we have to do, we have to determine the unbalanced force normal to the slider axis. So the unbalanced force which is created, normal means perpendicular to the slider axis. So this is your slider axis, ये हो गई आपकी स्लाइडर एक्सिस. तो इसके अनबैलेंस जो फोर्स आएगा वो हमको फाइंड आउट करना है, अनबैलेंस फोर्स, and this unbalanced force we have to find out. So this is the unbalanced force normal to the axis of slider, F unbalanced, ये हमको find out करना है, like this. In the solution, we know that unbalanced force, F unbalanced force, is the product of mass, balance mass, radius of crank, omega square with respect to the vertical component sine theta. So mass is how much? Mass is 6. Radius of the crank is 0.1. Then angular velocity is given. Angular velocity is 10 radian per second. Omega equal to 10 radian per second. So here it is 10 square multiplied by sine of theta, that is 30 degree. So from here we can find out the unbalanced force, and it is 30 Newton. So direct put the value and get the answer. So here there is no need of mass of the slider. It is superimposed data, उसका कोई काम नहीं आएगा. For unbalanced force we have to take the balance mass. Now similarly, next problem, problem number 3. The problem number 3 says that a slider crank mechanism with radius of crank 60 mm. So a slider crank mechanism with radius 60 mm, radius is given, length of connecting rod is 240 mm. Okay, so what is ratio N? L by R. So 240 divided by 60, 6 is cancel, it will be a 4. Now the uniform speed omega is given to you, 10 radian per second counterclockwise. For given configuration, the speed of slider will be dash. We have to find the speed of the slider, and the angle between crank and connecting rod is 90 degree. Okay, it is like this. For example, see, this is the crank, This is the axis of the slider, and this is the connecting rod. This is the slider. Okay. So this angle, this is crank R, connecting rod L. So between them, this angle, it is mentioned as 90 degree. ये given है बेटा. Okay. So as we know that angle of crank, as we know that angle of crank is what? Theta, and angle of connecting rod is beta. And similarly, we have to determine what? We have to determine the velocity of piston or velocity of slider. ये हमको find out करना है. Now, for determining the velocity of piston or velocity of slider, you should know the equation of velocity of piston. So, what is the equation? Omega r, then sine theta plus sine 2 theta upon twice n square minus sine square theta under root. This is the equation that we have seen in our previous slides and in analytical method, velocity and acceleration. So now tell me how to, we know omega 10 radian per second, we know radius 60 mm, that is your 60 into 10 raised to power minus 3 meter. So omega is known to us. The radius of the crank is also known to us, 60 mm. Radius of crank 60 into 10 raised to power minus 3 meter. Omega पता है, R पता है, N is also known 4. Okay, बचा क्या है? Theta. We don't know theta. We don't know theta. So how to find theta? So by using the trigonometry. By using the trigonometry. Trigonometry means in this triangle, tan theta equal to what? So tan theta will be 240 by R, that is 60. So from here you can find theta. Okay, 240 matlab this is L and this is R. So it is 75.9637 degree. So substitute theta as 75.96. From here you will get the answer, and it is approximately 0.6184 meter per second. After substituting all this value of omega, r, theta and n, okay, you will get this answer. Now come to the next problem. The next problem is a slider crank mechanism with radius what? R, 200 mm. Crank radius is 200 mm. Now let us go to this question. 90 degree, theta is given 90 degree. Here this is your theta. This angle is your theta. R is the radius of crank. L is the length of connecting rod. This is beta. Force आपको given है. It is 5 into 10 raised to power 3 Newton. A slider crank mechanism with crank radius 200 mm and connecting rod length 800 mm is shown. Okay. The crank is rotating at 600 rpm in counterclockwise direction. So n is given. So we can find omega 2 pi n by 60 if needed. In the configuration show, the crank makes angle of 90 degree with the sliding direction of the slider. Force is given, piston force, and we have to neglect the inertia forces, and we have to determine the turning moment on the crank. Turning moment is your torque. We have to determine turning moment on the crank. So we have to find TR or torque. We have to determine the torque. So in the previous problem, first problem, you have seen that torque, or just write T. Just write T. So torque is product of how it is rotating in counter. See, this is rotating in counterclockwise. So this will be your Ft at 90 degree, and this is R. So Ft into R. And what is ft? F upon cos beta sine theta plus beta into what? R. So this is the expression. Okay. This is your ft into R. Now here you can see that we know the value of crank angle theta, but we know the beta term. So again, as I have explained you that L sine beta equal to R sine theta. Very important relation. L पता है आपको, R पता है, you know theta. So from here you can find out what beta. You can find beta, and it is somewhat 14.47 degree. Okay. So when you will substitute the values here, you will find that अब आपको एम एफ पता है कितना है बेटा एफ 5 किलो न्यूटन इफ यू वांट टू फाइंड वो टॉर्क काय में निकालना है किलो न्यूटन में ना तो डू वन थिंग इफ यू वांट टू फाइंड द टॉर्क इन किलो न्यूटन डोंट सब्स्टिट्यूट इट इन न्यूटन सो एफटी विल बी 5 एफ 5 अपॉन cos 14.47 then sine 90 degree plus 14.47 degree multiplied by radius of the crank 0.2. Okay, from here you will get torque 1 kilonewton meter. This is your answer. It is a it is a question where a slider crank mechanism with non-zero masses and inertias were given to you, and what it has asked, a constant torque T is applied, constant torque T is applied to the crank as shown in the figure. Which of the following plots best resembles variation of crank angle? So see, best results means say it is directly proportional. It is not possible. Simple harmonic is also not possible, and parabolic is also not possible because in slider crank mechanism, because of the inertias, because of the frictions, okay, the crank angle and time does not obeys each other parameters. The best answer is this one. Answer D. This is the best plot which can resembles crank angle versus time flow graphical representation for a slider crank mechanism. Now, in this question, a slider crank mechanism, length of crank and connecting rod are equal. Okay, R equal to L. It is already given R equal to L. So if if for example, this is my single slider theta, this angle is beta, this is R and this is L. If R and L are equal, then it is 90 degree. Okay. And also if R equal to L, this implies N is L by R and L by R will be what? 1. The speed is given omega, angular speed of the crank is 14 radian per second and length of the crank is 300 mm, that is 0.3 meter. Okay. The maximum acceleration, very good, maximum acceleration. Now tell me, maximum, we have to determine what? Maximum acceleration. And already I have told you, if L equal to R, then R will be also 0.3 meter. Now tell me, maximum acceleration occurs when theta equal to what? Yes, maximum acceleration occurs when theta equal to 0 degree. And if theta equal to 0 degree, so if theta is 0 degree in the solution, maximum acceleration. See, already I have explained you here. See, acceleration equal to r omega square 1 plus 1 by n. Okay, and I've told you that maximum acceleration is at theta equal to 0 degree. So when theta is 0, okay, so this equation is comes to this reduced form, that is r omega square 1 plus 1 by n. So here it will be r omega square 1 plus 1 by n. Okay, so here if you will substitute all this value, you will get 117.6 meter per second square. So this is your answer. Now move to this question. Consider the triangle formed by connecting rod and the crank of an IC engine as the two sides of a triangle. Okay. If the maximum area of this triangle occurs when the crank angle is 75. So for example, this is my crank. How I will decide crank? I will fix this point. So this is my R and this is L. And this angle is theta, which is equal to what? 75 degree. And we have to determine what? We have to determine ratio of connecting rod length to the crank. We have to determine N. N is what? L by R. So we have to determine this ratio. Out of this four option, one option is correct. Actually, if maximum area of this triangle occurs, for maximum area, this angle has to be 90 degree. Therefore, I have highlighted this point. For maximum area, this angle has to be 90 degree. At that time, maximum area will be, this is your maximum area ना, ये maximum area कब बनेगा पूरा? When this angle is 90 degree. If this angle is 90 degree, then this is beta. Beta will be 15 degree. Okay. So I can say that for maximum area, for obtaining maximum area of a single slider mechanism, and if you want to obtain maximum area in terms of triangle, then length of then uh, connecting rod and radius of crank should be mutually perpendicular to each other. And if they are mutually perpendicular to each other, the angle between them will be 90 degree. And at that time, we will get the maximum area like this. अगर हमको maximum area है, तो this will your maximum area. This at in this point there will be maximum area. This area will be maximum. Okay, and this is your slider. So now let us move solution. In the solution, what is the sine rule? L sine beta equal to what? R sine theta. This is the rule, na? If we will follow this rule, we know length L, length नहीं पता, sorry, beta is 15 degree, R and theta is 75 degree. So L by R will be sine 75 degree upon sine 15 degree. So its ratio is 3.73. So this is the answer. Option C. So this is your option C. Now let us move to the straight line mechanisms. In kinematics of machine in unit number 1, a straight line mechanism topic is there. So a straight line mechanism means a mechanism which is used for producing straight motion, straight line motions. Okay. And these mechanisms may produce exact straight line motion and or approximate straight line motion depending upon their geometric constraint. And generally in this mechanism, there is either a turn, there will have only turning pairs or sliding pair is used in such type of mechanism. So this is the A category for straight line mechanism. Category is like this. Um, Straight line motion mechanisms are exact and approximate straight line motion mechanism. Exact straight line motion mechanism में दो कैटेगरी है. If only turning pairs are there, then Posler and Hart mechanism. In Posler mechanism and Hart's mechanism, there will be only turning pairs, no sliding pair. And if there is one sliding pair, okay, then exact straight line motions, it is a Scott Russell mechanism. So from here, directly you should conclude that straight line mechanism are of two types: exact and approximate straight line mechanism. If there are only turning pairs, it is Posler and Hart mechanism. If there is a sliding pair, then it is a Scott Russell mechanism. Then what is approximate straight line mechanism? So these are the categories: grasshopper mechanism, Watt's mechanism, Chebyshev mechanism, then modified Scott Russell mechanism, and the Robert mechanism. This comes under the category of approximate straight line mechanism. Now see, these are the two examples. One is the Posler mechanism having 8 number of links. Another one is your Hart mechanism consisting of 6 links. You can see that the pointer is tracing a straight line path. Therefore, it is known as an exact straight line mechanism. If you will, there are 8 links in Posler mechanisms. If you will determine the number of joints, okay, here there will be only lower pairs. Lower there will be only in and lower pair also there will be only turning pairs. So determine the turning pairs and you will get the answer, and the answer will be 1 for degree of freedom. Similarly, in Hart mechanism also, number of links are 6. Identify the number of joints and find the degree of freedom. It will be also 1, because output is a straight line. Na? Now, then exact straight line mechanism with one sliding pair. So here see, in Scott Russell mechanism, it is the Scott Russell mechanism is the modification of somewhat single slider crank mechanism. Here you can see that if you will eliminate this, see, 1 minute. If you will eliminate, if you will eliminate this portion, okay. If you will eliminate this first portion, it is a single slider crank mechanism. So this is a connecting rod. This is your what? Connecting rod. This is CR. Connecting rod. Okay. So by eliminating, this is your connecting rod. If this portion is eliminated, it is a single slider. For example, this is fixed link 1, this is link number 2, this is link number 3, and slider is your link number 4, and this is the extended part. Okay. Degree of freedom will be 1. Also, here it is a Scott Russell linkage, and here you can see this diagram. It is a Scott Russell linkage of Nissan vehicle, and it is attached on the rear axle. After this, see here, approximate straight line mechanism. Why it is approximately? Because you can see that it is not tracing the path in a straight line, but it is in approximate straight line. At some point, there is a curvilinear performance of it. Okay. So it is a wet mechanism. It also consists of 4 links. So it is the inversion of your 4-bar mechanism. Watt's mechanism is an inversion of your 4-bar mechanism. It also consists 4 links. And see the application. A wet mechanism is attached on the rear side of the vehicle, okay, to guide the piston. Now, these are also approximate straight line mechanism. One is your robot mechanism, okay, and next other one is your grasshopper mechanism. So robot mechanism is a non-Grashofian. Non-Grashofian means what? It does not obey the Grashoff's law. And what is Grashoff's law? Grashoff's law states that sum of the longest and shortest link should be less than or equal to remaining two links. Okay, so it does not obey the Grashoff's law. And if this two mechanisms, approximate straight line mechanism, if they does not obey the Grashoff's law, then they will come under the category of which mechanism? They will come under the category of class 2 mechanism. Important point. So a question can also come. um Roberts mechanism, grasshopper mechanisms obeys Grashoff's law, does not obeys Grashoff's law. ऐसा भी क्वेश्चन आ सकता है. तो नॉन ग्रेशोफियन डबल रॉकर मैकेनिज्म से ये दे डू नॉट ओबे द ग्रेशोफ्स लॉ, दे कम्स अंडर द कैटेगरी ऑफ. So this is the first part. Okay, this is the first part. Here we have completed the dynamic force analysis. Now what we will do, we will go to the flywheel part. Okay, let us start with the flywheel part. Okay, we will just see the flywheel. We will not go to the governor because related to governor there are no questions which are asked in the gate. Only flywheel is been asked. Screen is visible. Tell me, screen
Yes,
is
sir.
visible and voice is audible.
Yes, sir.
Okay, okay. Let us start now. So see, today our topic will be up to this flywheel. What is turning moment diagram? Then determination of maximum fluctuation of energy. Then what is coefficient of fluctuation of energy, coefficient of fluctuation of speed, then energy stored in flywheel, and switching presses and gate numericals. Okay, we will not cover this topic, governor, types of governor. So let us start with the flywheel. Now, what is a flywheel? So, as we have all studied in dynamics of machine in sixth semester about the governor and flywheel. So basically, flywheel is your reservoir. Okay, it is a reservoir which is used in machines and it stores energy and releases the energy as per the requirement. Now, the storing of energy is which type of energy? It is kinetic energy. It stores the energy in terms of kinetic energy, and how it releases when requirement of energy is there, it will release the energy, and when requirement of energy is not there, then it will store the energy. So it controls the variation in speed during each cycle. Similarly, its application in IC engines, then reciprocating compressors, then pumps, then crushers, then punching and shearing and riveting machines, etc. So here it has the application. Similarly, the next is your location of flywheel. So here you can see the location. Okay, this is the location between the crankshaft. This is the location of the flywheel. So it is located between the engine cylinder and the assembly line. This is the location. Generally what happens, so basically what we have to do here, we have to see the turning moment diagram. Our area of study is to see what is the turning moment diagram for in steam engines, for internal combustion engines, for multi-cylinder, for two-cylinder, four-cylinder. We have to see the turning moment diagram. So it is somewhat related to dynamic force analysis. Now, here turning moment diagram. So what is a turning moment diagram? Actually, it is the graphical representation of torque versus theta. Torque versus theta means what? For example, this is my x and y axis, this is my theta, that is the crank angle, and this is my torque. So here the graphical representation is known as the turning moment diagram. So basically during one revolution of crankshaft of steam engine, the torque varies. This equation we have seen in the previous topic, that is the dynamic force analysis, that is T equal to Fp into R. Now, as we know that flywheel is used to store the energy, and the energy stored is in the terms of kinetic energy. Okay. Now, for example, um, if we will compare it with the governor, if we will compare flywheel with the governor, so governor is controlling the fuel supply and flywheel is controlling the energy fluctuation. That is the basic difference between them. So coming to our main point, we have to see the turning moment diagram, okay, for various applications. And a student should know that torque is the product of force into crank radius into sine to theta plus sine to theta. So this equation you have already seen in dynamic force analysis. So I will not repeat this equation. And the turning moment diagram application is that it helps to design and it helps to design the dimensions and mass of the flywheel. That is the best example. Now let us go to the turning moment diagram. From here we will start. See in this diagram, actually it is the turning moment diagram for a single cylinder double acting steam engine. Okay, on x-axis this is your crank angle, and on y-axis this is your torque, and it is the diagram. It is just a diagram for your explanation. So as you know that one cycle, in this diagram it is being shown that one cycle is completed in 0 to 2 pi. 0 to 2 pi means this is 0 degree, pi by 2 means it is 90 degree, 180 degree, okay, then 270 degree, and then it is 360 degree. So one revolution of crankshaft is used to complete the cycle. Now in this cycle you will see this is your T mean line, this is your एवरेज लाइन. ये एवरेज लाइन का मतलब हो गया कि एवरेज लाइन के ऊपर अगर आपका टॉर्क डेवलप होता है तो वो एक्सेस टॉर्क हो गया, और एवरेज लाइन के नीचे हमको रिक्वायरमेंट है टॉर्क की. दैट इज द बेसिक कॉन्सेप्ट, दैट इज योर एवरेज लाइन. नाउ let us start. See, in the first half means from position OA to position OB, or between 0 degree and 180 degree. So between 0 degree and 180 degree, you will see that this is the actual position A, F. This is the actual position. This is the requirement, work done. Okay, ये requirement हमको चाहिए. तो requirement कौन सी है? A है, F है, H है, B है. So this is the requirement of work done, and you can find that this is your excess requirement. This is your excess. ये excess है. This is your excess requirement. Okay, so the the system wants only requirement A, F, H, B. This is the requirement of the system. But excess is FGH. So this excess requirement will be stored in flywheel. Excess energy will be stored in flywheel in terms of kinetic energy. Similarly, during 0 O to C and O to D, okay, O2A and O2B you have seen. Now O2C and O2D. This is the requirement needed. और यहाँ पर भी आपको एक्सेस मिल रहा है तो this will be stored. So I can say that during position, now see I am summarizing this. How I am summarizing? I am saying that during position OA to OB and position OC to OD, flywheel stored excess energy, and this is the excess energy. This is the excess energy stored by the flywheel. Excess energy means the speed is increased. Okay, and flywheel stores the energy. Similarly, during position OB to OC. Now see, this is the requirement. BHJC. This is the requirement. ये requirement है. But only this requirement is fulfilled. ये इतना requirement हुआ है. Actual requirement is what? BHJC. This is the requirement of energy. But HPJ is the requirement which is developed. So here this remaining requirement, HBP, this requirement ये बचा है, and this requirement has to be fulfilled. And for this purpose, what flywheel will do? Flywheel will release the energy so that the requirement gets fulfilled. So यहाँ पर रिक्वायरमेंट पूरी नहीं हो रही है तो लॉस ऑफ वर्क है, स्पीड कम हो रही है तो फ्लाईव्हील विल रिलीज वर्क. अगर लोड बढ़ रहा है इंजन में तो स्पीड कम हो जाएगी, अगर स्पीड कम हो रही है तो फ्लाईव्हील रिलीज करेगा एनर्जी. सो दिस इज द बेसिक कॉन्सेप्ट. हियर यू कैन सी दैट through the turning moment diagram, this is the maximum speed from A to B and maximum speed from to D. Similarly, minimum speed will be this from B to C and from D to A. This will be the minimum speed. ये minimum speed है, and here at the peak point this will be the maximum speed. So fluctuation of speed is maximum minus minimum. Now in flywheel there are two types of cycles. One is intra-cycle, another one is inter-cycle. Intra-cycle का मतलब क्या हुआ? Intra-cycle means maintain the speed over one cycle. एक cycle में आप speed maintain कर रहे हो, यानी one revolution of crankshaft, cycle is completed. Cycle is completed in 2 revolutions of crankshaft, मगर per the cycle is completed. Okay, for example IC engine where fluctuation is caused during one cycle, so that is intra-cycle. Similarly, intercycle. Intercycle means maintain speed over a range of cycle. For example, a power plant. A power plant is operating throughout the day. It is not like your IC engine कि यहाँ से आपको if you want to go 40 kilometers तो 40 kilometers तक वर्क हुआ फिर बंद हो गई गाड़ी. In power plant what happens? It is along the shift wise, first shift, second shift, third shift, so continuously it is working. So continuously for a longer continuously we have to maintain the speed over a range of cycles. Okay, there will be number of ranges over a full span day wise, so it is known as intercycle. So basically intracycle is used to maintain the speed over one cycle, and intercycle is to use to maintain the speed over a range of cycles. So this is the difference between intra and intercycle. Now let us see the turning moment diagram for 4-cylinder. Turning moment diagram for 4-cylinder IC engine. As you all know that in 4-stroke engine, there are, the first is your suction stroke. Suction stroke means the pressure inside the engine cylinder. The pressure is inducted inside the cylinder in terms of air fuel mixture or just diesel for CI engines. Okay, I am taking the example of SI engine. Similarly, second is the compression stroke. The product of air fuel mixture is compressed. Then third is your power stroke or expansion stroke. Okay, where the ignition, the ignition process is done and power is developed. And the last one is your exhaust stroke. And in exhaust stroke, the exhaust gases are scavenged and goes to the atmosphere through the exhaust pipe. So now these are the basic four stroke. We have to see the turning moment diagram. Okay. Now in turning moment diagram, let first of all in turning moment diagram of four stroke engine, the cycle is completed in two revolutions of crankshaft. For example, 0 to this is 180 degree, this is 180 degree, so it is 360 degree, again 180 degree, again 180 degree. So cycle is completed in two revolutions of crankshaft. So cycle is completed in two revolutions of crankshaft. Okay. So now during suction stroke, what happens? This is your mean line, and below the mean line is negative, and above the mean line is positive. So here, during suction stroke, pressure inside the engine cylinder is less than the atmospheric pressure. And if the pressure in the engine cylinder is less than atmospheric pressure, a negative loop is formed. Negative loop means power will be supplied to the engine from the flywheel. Therefore, negative loop. So this is your negative loop. This is negative loop. This is negative loop. Above it, positive loop, negative loop. And this is a small amount of positive loop. So here from 0 to 180 degree, you can see that a negative loop is developed. It means a power is supplied to the engine, and here it is a very small amount of a positive loop. यानी जैसे जैसे सक्शन स्ट्रोक कंप्लीट हो रहा है, हल्का सा पावर डेवलप हो रहा है इंजन से. That is the meaning. Then in compression stroke also, a larger negative loop is formed. It means that work is done on the gases. Therefore, negative loop. The third is your power stroke or working stroke or expansion stroke. Here you can see a very high positive loop is formed because it is a power stroke. Here combustion process takes place. And after the combustion, the gases will expand and work will be done on by the gases on the system. In positive loop, work is done by the gases on the system. That is power developed by the engine. In negative loop, work is done on the gases. It means power is supplied to the engine. That is the difference. And the last one is your exhaust stroke. Okay, so this is the actual diagram. But in numerical, what we do, we draw the, we assume total for just for the simplicity of writing equations. This is suction stroke, then this is compression stroke, then this is your power stroke, and then this is your exhaust stroke. Okay, so in while solving the numericals, we assume this condition like this. This is your torque, this is your crank angle, and this is your mean torque. Not mean torque line, mean torque. Okay, this is your, this will be your mean torque line like this. So now let us move to the multi-cylinder. Actually, in multi-cylinder turning moment diagram, for example, there are four cylinders. In an engine, there are four cylinders and all the cylinders are simultaneously working. Okay, it is not a single cylinder engine. It is a multi-cylinder. There are four cylinders, there are 8 cylinders, 12 cylinders, which are continuously working. So always in some cylinder there will be suction stroke, in some cylinder there will be compression stroke, in some cylinder piston arrangement there will be expansion stroke, and in some there will be exhaust stroke. So continuously, so basically turning moment diagram of each cylinder is obtained separately, and then all the turning moment diagram are combined with each other, and they are superimposed over each other, with starting point shifted to the phase difference of the angle between the respective crank position. So for example, see, in this diagram I will manipulate it here. For example, this is turning moment diagram of one cylinder, this is turning moment diagram of another cylinder, this is turning moment diagram of another cylinder, this is turning moment diagram again of other cylinder. So there are four cylinders. So what I will do, by using the phase difference, I will superimpose all this turning moment diagram into a single turning moment diagram like this. Okay, so this is the multi-cylinder engine concept. Now determination of maximum fluctuation of energy. Here, this is the turning moment diagram of a multi-cylinder engine. Okay, so there are number of cylinders and all the turning moment diagram are incorporated through a single turning moment diagram, and all the values are simple superimposed. Now for example, let the energy at point A be E. Above the main line positive, negative, positive, negative, above positive, below the main line it is negative. So let energy at A equal to E, that is I have assumed. Now what will be the energy at B? Energy at A plus energy within AB. So energy area, this area is A1. So energy at B will be energy at E plus this area. So it will be E plus A1. Now energy at B will be what? And energy at B will be from here C. Energy at energy at C will be what? So energy at B. So energy at B is what? E plus A1. This is the energy at B. Okay. And from B to C, this is the negative loop. So area will be minus A2. So this is minus A2. Similarly, energy we have to determine at D. So energy at C is what? Energy at C is E plus A1 minus A2. And this is plus A3. Similarly, the process is repeated. And you will find that at the last, the energy at the last point will be equal to A, and it is equal to what? E. So this is the condition. So we have find, for example, if we want to find energy at E, so what we will do, energy at A, energy, we have to determine energy at E, for example. So energy at A, that is capital E plus A1 minus A2 plus A3 minus A4. So this is the energy at E. अगर हमको energy at F चाहिए तो ये पूरा टर्म रहेगा, okay, this whole term plus A5. And when if you want to find energy at G, so energy at G, if when you will see all the terms will be cancelled and only E will be left out. So let us assume that if energy, all these are all the energies, and here if I know the values of A1, A2, A3, A4, A5, A6, then what I can do, I can find the fluctuation of energy. कैसे? Let us assume that energy at B is maximum. ये maximum है, let us assume, okay? And at F it is minimum. So maximum minus minimum energy will be your fluctuation of energy. So when the values are known to us, A1, A2, A3, A4, A5, A6, then we can find energy at each junction point. And after finding the values, we can select which is the maximum energy value and which is the minimum energy value. And then taking the difference of maximum energy and minimum energy, we can find the fluctuation of energy. Now some basic definition, coefficient of fluctuation of energy. So it is actually the ratio of maximum fluctuation to the work done per cycle. कितना fluctuation हो रहा है with respect to work done per cycle. So work done per cycle is what? It is the product of T mean into crank angle. Okay. Then what is coefficient of fluctuation of speed? It is the ratio of difference in speed to the mean speed. N is the mean speed. Here the value of N is your mean speed. N is your mean. Okay. Mean means what? Maximum plus minimum divided by 2. So here what I have done, instead of n mean, I have substituted n1 plus n2 by 2. और जो 2 था वो it is shifted to numerator. So the CS is 2 n1 minus n2, n1 plus n2. And what is coefficient of steadiness? So actually it is the reciprocal of coefficient of fluctuation of speed. Reciprocal of CS is the coefficient of steadiness, which is denoted by m. Here, coefficient of fluctuation of energy is maximum fluctuation of energy to the work done per cycle. This is the expression. Now let us say theta T mean. Let T mean be the mean torque, theta be the angle in one revolution. Now theta equal to 2 pi in case of steam engine and two-stroke internal combustion engine. Theta equal to 4 pi in case of four-stroke internal combustion engine. As we know that power is what? Product of T mean into omega. This is the basic mechanics. Okay, power equal to T mean. And what is omega? Omega is 2 pi n by 60. Okay, this is the equation. So power multiplied by 60 divided by 2 pi n is your mean torque, which is represented here. Now, what is work done per cycle? Work done per cycle is P into 60 divided by N. Here, what is small n? Number of working strokes per minute. So, in case of steam engine, number of working stroke equal to capital N, that is the speed in RPM. And for four stroke, the working stroke is capital N by 2 in case of four stroke internal combustion engine. Now, energy stored in flywheel, important derivation, and in flywheel related to this derivation, the question has been asked. Okay, so if you know this derivation, you are capable enough to solve the problems related to the gate. So here a flywheel, we have to determine the expression for energy stored in the flywheel. Now here what we have done, we have considered a flywheel. This is the flywheel. This is your hub. This is the rim. It has a arm somewhat. There are four arms in there. R is the radius. So this is a cross-sectional view of a flywheel, shape of a flywheel. Here we have assumed that let m equal to mass of the flywheel, k equal to radius of gyration of the flywheel, then I be the mass moment of inertia of the flywheel, and it is equal to mk square. But please make a note that mass moment of inertia depends upon the shape of the flywheel also. Okay, for solid circular disc it is I equal to mr square by 2. Then as kinetic energy, what is kinetic energy? Energy stored in the body by virtue of its motion, that is your kinetic energy. Now, so as kinetic energy is what? Half I omega square. In linear it is what? Half mv square. For angular it will be replaced. Mass will be replaced by mass moment of inertia, and linear velocity will be replaced by angular velocity. So here energy is half I omega square, and what is I? Mass moment of inertia, which is equal to mk square. So हमने what we have done, instead of I we have substituted mk square into omega square. Now we have seen that fluctuation of energy, maximum fluctuation of energy is the difference between maximum energy and minimum energy. So here also maximum fluctuation of energy will be maximum kinetic energy minus minimum kinetic energy. So let us assume that half I omega 1 is the maximum speed and 2 is the minimum speed. So half I omega 1 square minus half I omega 2 square. Omega 1 and omega 2, maximum and minimum. Maximum speed, minimum speed. Then I is common. Omega 1 square minus omega 2 a square minus b square. So it will be a plus b, a minus b. Now here what we have done, we have multiplied by 2. If I will multiply it by 2 to the numerator and denominator, okay, so 2 will be get cancelled like this. See, here I have done, here it is actually delta E equal to I am explaining this expression. How? After this expression, how this expression has been come. Okay. Half into I omega 1 plus omega 2 into omega 1 minus omega 2. So first of all, what I will do, for example, if I will multiply it by, if I will multiply to the numerator omega and to the denominator omega, like this, या उसके भी पहले एक टू टू का टर्म ला देता हूं, टू and 2 like this. So now the expression will be delta E, 2 and 2 get cancelled. Here I omega 1 plus omega 2 by 2. Okay, so it will be n1 omega 1 plus omega 2 by 2 will be your omega into omega 1 minus omega 2 average. Omega is what? Mean speed, and mean will be omega 1 plus omega 2 divided by 2. उसको मैंने सिर्फ ओमेगा से डिनोट किया हूं. Here now what I will do, I will multiply it by omega to the numerator and denominator. If I will multiply omega to the numerator and denominator, for example, okay, so I into omega will be omega square, omega 1 minus omega 2, and here there will be omega. So delta E will be I, ये हो गया omega square. What I have done, simply omega, I have done like this, multiplying omega to the numerator and denominator. So it is I omega square omega 1 minus omega 2 upon omega, and omega 1 minus omega 2 upon omega is what? CS. CS is omega 1 minus omega 2 upon omega. So I omega square CS, then mk square omega square CS. Instead of I is what? Mk square. So what we have done, for energy stored in flywheel, I is there, omega square. So instead of mk square, and instead of omega 1 minus omega 2 upon omega, I have written CS. Okay, so this is the expression. Delta E equal to I omega square CS, or delta E equal to mk square omega square CS. Okay, and similarly, as we know that E equal to 1 by 2 I omega square, so I omega square can be written as twice of E. तो here instead of I omega square हमने twice of E लिख दिया है. See, I omega square equal to what? 2 into E. ठीक है, तो दिस इज द एक्सप्रेशन, दिस इज द एक्सप्रेशन. सिमिलरली यहाँ पर ये भी एक एक्सप्रेशन है. तो इफ यू नो दिस इक्वेशन ना, यू कैन सॉल्व द प्रॉब्लम. ओके, so let us go to the problems. Here a flywheel connected to a punching machine has to supply energy of 400 Newton meter. A flywheel connected to a punching machine has to supply energy of 4 Newton meter. Okay. So supply of energy is how much? Delta E equal to 400 Newton meter at an angular speed omega 20 radian per second. Total fluctuation CS is plus minus 2%. Now what is plus minus 2%? See, this is your mean CS. Okay. So here fluctuation is plus 2% and here fluctuation is minus 2%. So total fluctuation will be 4%. Okay. तो CS will be 4%. हमको प्लस माइनस मीन्स ऊपर भी प्लस और नीचे भी प्लस. मीन वैल्यू के दिस इज मीन स्पीड, दिस इज योर मीन स्पीड. तो मीन स्पीड के ऊपर भी 2% फ्लक्चुएशन है, मीन स्पीड के नीचे भी. टोटल 4%, 4 मीन 0.04. एंड व्हाट वी हैव टू डिटरमाइन? वी हैव टू डिटरमाइन आई. Solution. In the previous derivation, you have seen that delta E equal to what? I omega square CS. ये आपने देखा. Delta E equal to I omega square CS. Now, so delta E is 400, I is mk square, I तो निकालना है, omega is 20 square and it is 0.04. So directly you can find the answer. 20, it is somewhat 25 kg meter square. Now, in second problem, generally in flywheel, mass moment of inertia is been asked to determine the mass moment of inertia. This problem is very simple. Here, we have to determine the mass moment of inertia. Maximum fluctuation of kinetic energy in an engine has been calculated to. So delta E is 2600 joule Newton meter. Speed is average speed is 200 rpm. So average angular speed will be 2 pi n by 60, 2 pi n by 60. So it is what, 20.94 radian per second. Then the polar mass moment of inertia we have to determine, and CS is plus minus 0.5%. So plus 0.5, it will be 1% equal to 0.01. And we have to determine what? Mass moment of inertia. So here you can go to the solution. What is delta E? Delta E is I omega square CS. यहाँ से आप लोग को I मिल जाएगा. You know delta E, you know omega, you know CS. So I is 592.95 kg meter square. Okay. Now in next problem, here important क्वेश्चन है, डायग्राम गिवन है. जनरली स्टूडेंट गेट्स कंफ्यूज और घबरा जाते हैं इस टाइप के डायग्राम देख के. देयर इज नो नीड. इफ यू नो दी टर्निंग मोमेंट डायग्राम कॉन्सेप्ट, तो you are familiar with that triangular diagram, so there is no issue of getting frightening. Now see, this is the diagram of what? Torque and theta. Okay. And this is the diagram of angular speed with respect to the crank angle theta. And what we have to do? A torque and angular speed data. This is torque and this is angular speed data over one cycle, that is 360 degree, for a shaft carrying a flywheel are shown in the figures. The moment of inertia of the flywheel is, we have to determine the moment of inertia. Now for determining the moment of inertia, see, for example, what is moment of inertia? Delta E equal to what? I omega square CS. This is the basic equation to determine the mass moment of inertia I. मैं यहाँ लिख देता हूँ. I will use another pen. हाँ, what is delta E? डेल्टा ई इज आई ओमेगा स्क्वायर सी एस, और यहाँ से बेटा आप लोगों को निकालना है आई। अब आई निकालने के लिए डेल्टा ई इज नॉट गिवन, omega is not given, cs is not given, but two diagrams are given. Instead of values they have given the diagram, so with the help of diagram you can find. How you can find? So see, first target, how I will find delta e by using this torque and theta diagram. Delta e is the fluctuation of energy, तो यहाँ पर fluctuation का हो रहा है, ये हो रहा है, this is the maximum fluctuation. So from here I can find what? Delta e. Now this is the, actually it is a rectangle, तो डेल्टा ई इक्वल टू, फ्लक्चुएशन तो नीचे भी हो रहा है बट इट इज मैक्सिमम, हाँ, इट इज मैक्सिमम फ्लक्चुएशन दैट आई हैव टू कंसीडर। ये है -1500 और ये है 3000 का फ्लक्चुएशन। अब इसका एरिया, टेल मी द एरिया बेस इनटू हाइट। तो व्हाट इज द बेस? दिस इज द बेस, ये बेस है, तो दिस इज पाई एंड दिस इज पाई बाय 2, तो पाई माइनस पाई बाय 2 इज द बेस। एंड व्हाट इज द हाइट? हाइट दिस इज 3000 minus this is 0. So it will be pi minus pi by 2 means 2 pi minus pi by 2. 2 pi minus pi by 2, so it will be just pi by 2 multiplied by what? 3000. So it will be 1500 pi. So see, with the help of this diagram you have determined delta E. अब लगता है ओमेगा यानी स्पीड, एंगुलर स्पीड की भी देखो, इन दिस डायग्राम दिस इज द मैक्सिमम स्पीड and this is the minimum speed. So what is omega? Omega is the mean speed. What is mean speed? Maximum plus minimum divided by 2. So maximum is 20, minimum is 10, divided by 2, 20 plus 10, 30, 30 by 2, that is 15, that is 15, 15 radian per second. Okay, now, so CS will be, and what is CS? CS will be omega max minus omega minimum divided by omega. So omega max 20 minus 10 and omega mean is 15. So it is 0.7. So now delta E will be, sorry, not delta E, directly I will use the equation. So this implies what is delta E? 1500 pi equal to I multiplied by 15 square multiplied by 0.67. तो यहाँ से आपको मास मोमेंट ऑफ इनर्शिया मिल जाएगा 31.25 kg meter square. So see, by using the graph also you can find it. So see, we have here, um, we have completed the flywheel topic also. We have also completed the dynamic analysis of linkage within this 2.5 hours. Okay, and if uh, next schedule is been if in further schedule, okay, we will also go to the vibration topic also, and we will cover the vibration in force vibration. So that is from my side. Thank you for the cooperation and listening. Please go through these videos and practice, and if there is any difficulty you can directly